Dear students, this is Roseline, Assistant Professor, PG Department of Computer Applications, St. Joseph's College of Arts and Science, Cuddalore. Now, I would like to give an introduction about Database Management System and Relational Database Management System. We'll see what is a database management system. It is a collection of interrelated data and a set of programs to access the data. The database management system provides an environment that is both convenient and efficient for the user. We see the applications of database management system, banking, which may include all transactions, airlines, which will include reservations and schedules, universities will have applications like registration and grades, sales may include customers, products and purchases. Similarly, manufacturing will include production, inventory, orders and supply chain. Human resources will have employee records, salaries, tax deductions. Databases touch all aspects of our lives. Why do we use database management system? To avoid data redundancy and inconsistency, multiple file formats, duplication of information in different files are used. To avoid difficulty in accessing data, it is necessary to write a new program to carry out each new task. To deal with data isolation, multiple files and formats are used. To deal with integrity problems, integrity constraints become part of your program code, easy to add new constraints or exchange existing ones. The next one is atomicity of updates. Failures may leave databases in an inconsistent state with partial updates carried out. Example, transfer of funds from one account to another should either complete or not happen at all. Concurrent access by multiple users. Concurrent access need for performance. Uncontrolled concurrent accesses can lead to inconsistencies. Example, two people reading a balance and updating it at the same time will lead to inconsistency. The last problem is security problem. This is the overall architecture of database management system. In the first level, various users are used. They are naive users, application programmers, sophisticated users, and database administrator. The naive user will interact with the database management system with the help of application interfaces, which are again translated as an object code using application program object code. Then this is evaluated with query evaluation engine. The application programmers use application programs. These are compiled using compiler and linker. Then it will generate application program object code. Finally, again it is evaluated with query evaluation engine. Sophisticated users use query tools which are translated with DML queries and DML compiler and organizer. Then it is evaluated with query evaluation engine. Similarly, the database administrator use administration tools which can be translated with DML queries as well as DML interpreter. In the query processor, these are all the common components in order used to translate the query. Then in storage manager, buffer manager, file manager, authorization integrity manager and transaction managers are available. Disk storage will have data, indices, data dictionary and statistical data. Database users. Users are differentiated by the way they expect to interact with the system. Application programs interact with the system through DML calls. Sophisticated users form requests in a database query language. Specialized users write specialized database applications that do not fit into the traditional data processing framework. Naive users invoke one of the permanent application programs that have been written previously. Example, people accessing database over the web, bank tellers, client staff. We'll see the database administrator. The database administrator coordinates all the activities of the database system, has a good understanding of the enterprise, information resources and needs. Database administrators' responsibilities include schema definition, storage structure and access method definition, schema and physical organization modification, granting user authority to access the database, specifying integrity constraints, acting as liaison with users, monitoring performance and responding to changes in requirements. Transaction management. A transaction is a collection of operations that performs a single logical function in a database application. Transaction management component ensures that the database remains in a consistent state and despite system failures and transaction failures. Concurrency control manager controls the interaction among the concurrent transactions to ensure the consistency of the database. The storage management. Storage management manager is a program module that provides the interface between the lower level data stored in the database and the application programs and queries submitted to the system. The storage manager is responsible to the following tasks: interaction with the file manager, efficient storing, retrieving, and updation of data. The application architecture is classified into two types. One is two-tier architecture, another one is three-tier architecture. These two architecture are again classified into two parts. One is client part and server part. Example, for two-tier architecture, client programming uses ODBC, JDBC to communicate with the database. Three-tier architecture use web-based applications and applications built using middleware. This is the overall database management system which allows the user to create, manipulate, and access the data. This is the sample relational model. This is nothing but a table with various attributes. This is the table. These three tables are related with each other. This is the structure of the schema. A schema can be defined like this. That is, for example, in order to create a schema product with the following attributes: P-name, price, category, and manufacturer. This can be defined as product of P-name, price, category, and manufacturer. This is the product table with some sample data. Thank you.